Hello and welcome to Sunday's edition of Cracking the Cryptic, where we've got one of my favourite types of puzzles to have a go at today. Well, not just because it's by the maths professor Dorlir, but also this is a one-star puzzle, which means in theory at least it should be very approachable. And yet apparently it is just absolutely magnificent. We've had this recommended to us loads of times over the last day or so. And actually Dorlir himself also submitted it to us as well. So I think we're in for an absolute treat. Why do I love one-star rated puzzles? Well, I think these perhaps are the best way of showcasing to the world how incredible these variant Sudokus are that we do every day. And just look at the comments on this one. I just snipped these before I turned on the webcam. And Marty says, who I met yesterday, actually, I'm more on that in a moment. Codec, too good to be true. I mean, Codec saying that. Math Pesto says, brilliant. I really am looking forward to it. I mean, what we do on the channel is we try and bring you every day an absolutely world-class puzzle, and I think that we do that. But when we can bring you an absolutely world-class easy puzzle, that's really hard to do, because often if a puzzle is too easy, it loses a bit of its interest factor. But when one of these constructors achieves sort of interesting and approachable, that is an absolute sweet spot. So I'm looking forward to trying this, and we will do that together in a moment or two's time. Now, what else can I tell you about? I'm going to tell you about yesterday, where Mark and I went up to London and participated in Dash, different area, same hunt. So it's like this puzzle hunt that takes place all across part of London, or perhaps you've done it in what I think it certainly happened in lots of cities in the States yesterday. I think even in Tokyo and places like that. But it was a lot of fun. Incredible how Dash has grown as well. So I think yesterday there were over 300 people taking part. Now I remember in the first Dash that ever happened in London, perhaps there were 30 or 40, but there certainly weren't 300. So it's fabulous how it's all grown. I met lots of people who watched the channel, which was a great thrill. And thank you to everybody who came up and introduced themselves and told us that you enjoy watching Cracking the Cryptic. We did appreciate that. We enjoyed it. Well, we enjoyed it immensely. What else can I tell you about? Lots of stuff, actually. I've got birthdays a go-go to do today. But let's firstly talk about streaming. We're streaming tomorrow. My computer... Does your computer ever turn itself off? When this happens, it really messes me up, especially when my browsers don't remember what I had open at the time. Anyway, we're streaming this game called Rita, which is some sort of puzzle-related thing. Well, unsurprisingly, it's puzzle-related, but it seems to have a map. It's a bit like Mario, but with crosswords, is how I'm going to think about it. I hope that turns out to be true. 10 p.m. UK time tomorrow. Love to have your company if you're interested. What else? Oh, we should check out where we are with our monthly competition. We've still got about a week left. This is Back to the Future by Blobz. Over on Patreon right now. You can see these are the names of some of the puzzles. Now, this is going to reload. There, I think that's probably just reloaded there. So if that's right, we've had 786. I will just reload it again. Yeah, okay, so that is right. So we're up to nearly, not far shy of 2,000 souls of the first puzzle, and not that far shy of 1,000 souls of the final puzzle, which is terrific. So very well done to everybody who's managed to solve all the puzzles. That is terrific solving indeed. It's over on... How do I do this? I'll put it there. It's over on Patreon right now. You've still got plenty of time if you want to enter. The closing date's the 20th. The prize, we'll solve a puzzle together, which I hope might interest some of you. I've got to record with Michael, who won last week's competition, in the next few days. So we'll sort that out soon. And there's going to be some videos going up of my attempt at a listener crossword called Spider by Saber. So that's crossword content that'll be over on Patreon soon. What else? What else can I tell you about? I'm going to say thank you to Alice. Alice wrote to us. Alice is I think soon to be a PhD maths student. but actually wrote a real letter to us, which is sort of by snail mail, and included a copy of Cain's Jawbone, which is a brilliant puzzle book. So Alice, thank you for doing that. We did appreciate it, and it's a lovely thing to get a real letter. And let's do some birthdays as well. We'll start off with Guy. Now I think it's Guy. I have met people with the name Guy who've been called Guy in the past, but I think I'm going to go for Guy, who's 67 today. Over in Chicago. I know this because your wife Ursula wrote to us. That could be Ursula as well. I could be butchering everything here. I'm so sorry if I am. But Guy is an expat in Chicago, and apparently went to King's College, Cambridge, one of the most beautiful places to study in the whole world, and has a PhD in physics from there. I get massive imposter syndrome when I hear about all these fantastically intelligent people who watch the channel. I don't understand it at all. But anyway, Guy, many happy returns. I hope you have a brilliant birthday today, with, of course, chocolate cake. Next, we'll say happy... Oh, this is for yesterday. I'm late with this one. Lance, it was your birthday yesterday. You found Cracking the Cryptic in your last year of senior school, where you were bored out of your mind, I believe, and now you're at college, you're still watching when time allows. So thank you for watching. I hope you had a brilliant birthday. I'm sorry I'm a day late with the birthday wishes, but I hope the chocolate cake was good. Next, Hanno. Hanno, it's your birthday today, and I know this because your partner Terry wrote to us and told us that these puzzles bring you so much joy. Well, join the club. Join the club, my friend. They do bring a lot of joy, don't they? And Hanno, I hope you have an absolutely terrific birthday today with good cake, of course. Now, I'm a bit worried about the quality of cake. Over in Denmark, Adrian, you've turned 21 today, and I know this because your girlfriend Caitlin wrote to us and told me that you are having lemon and blueberry cake. No, you can't do that. What a waste of calories. No, that's awful. So maybe sneak some chocolate cake as well. That would be my recommendation. The two of you watch together and find it amusing to copy my thinking poses. What do you mean my thinking pose? I don't have different poses for thinking. Do I? I must do. Anyway, Adrian, many happy returns. And then finally, a late birthday again for yesterday. Emily, you turned 30 yesterday, and I know this because your partner Emmett wrote to us and told us that you were spending the weekend camping in Crieff, Perthshire, which is a very beautiful part of the UK. But I'm imagining, based off the weather I've got down here, that it must have been pretty wet for camping. I hope you didn't get too soaked, and you got some good weather, and you enjoyed camping. I myself would not be a good camper. But Emily, I hope you had a great birthday, of course. I hope you found some cake. That's all the news. Let's have a look at Half Circles by the maths professor Dorlir. And I will read you the rules, and we'll have a look at the puzzle together. So the rules are as follows. We have got normal Sudoku rules apply. So we've got to put the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. A digit n placed inside a circle or semicircle indicates that exactly n full circles in the grid contain the digit n. And then it explains, that there is no scrolling as well here. This is all the rules. So the next paragraph completes the rules. It says, 2 semicircles together count as 1 full circle. For example, if there are 4 semicircles containing the digit 5, right, 5, 5, 5. How many did it say? 4. I'll put a 5 there. Okay. And 3 full circles containing the digit 5. Oh, bob it in somewhere. Can I not? Oh, hang on. I'm going to have to move these about a bit. Hang on. How many semicircles? I've now got 4. And did it say 3? Yeah, maybe that might work. Then the total count. Yeah, the total count is what we'd expect. So each semicircle only counts as half a circle. So those four 5s there only contribute 2 circles, 2 full circles in total, and these full circles contribute 3 full circles. So altogether there are indeed 5 fives in circles, even though there are 7 fives in the grid. This is very, very bonkers. But they are all, that is literally all the rules. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. I sincerely hope that this puzzle doesn't cause us or me as much trouble as one of those puzzles yesterday. The puzzle with the pedestrians protesting. That was what did for us. Right, normally with circles puzzles, the idea is that you add up the number of circles. Now here that's going to be, it's almost easier to count the cells that don't have things in them, isn't it? We've got, let's do it. We've got 7, 10, 11, 12, 13, 14, 15, 15, 21, 23, 24, 27, 29, 30, 34, 36, 38, 40. Now I'm going to actually do that again, because if you do get the count wrong for the circles, which I have done in the past, it really is a problem. So 4, 7, 8, 13, 16, 17, 19, 25, 27, 31, plus 5 is 36, 40. Okay, I've got 40 twice, so that's probably 40. So 40 semicircles, which equates to 20 complete circles. Now, how many complete circles? Can I do? Oh, no, I can't. I wondered if I could double click them. That would have been useful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, let's do it again, counting rows. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, right. So we've got 16 full circles and the equivalent of 20 semicircles. So that's 36 circles in total. Now, let's just give that a little bit of thought in the context of a secret. Now, a secret, it's the secret of Sudoku. It's something I share with only my very favourite people. Of course, if you're watching this, you're one of my favourite people. The secret of Sudoku is that the Sudoku digits 1 to 9, if you sum them, you get 45. And that's incredibly important in so many of these puzzles. Now, that means that it's actually impossible, given this constraint, for us to have more than 45 circles in the puzzle. Because let's imagine the digit 8. If we put a digit 8 into a circle, there should be 8 circled 8s, or the equivalent in semicircle things. So there couldn't, so if we put 1 of every digit into a circled cell, then we get to 45 equivalent circles. For example, actually, let's use the digit 1. If we put 1 into that circle, no other 1 can be in a circle, because there's only one circled 1. So there should be 8 ones that are not in circles. So the maximum number of full circle equivalents is 45. Now, what did we say? We were 36 here. So there are 9's worth of digits that are not circled. And but the thing is, that could mean 9 itself is not circled, and then every other digit is circled. Or it could mean digits that sum to 9 are not circled. So, for example, 1, 3, and 5 might not be circled. So is it, well, here's a question. Is it actually possible for 9 to be never in a circle? Might it, oh, hang on, Maverick's flying over, sorry. Actually, it might be possible for, no, oh, hang on, no, that's still okay. That's suspicious, actually, isn't it? So you can actually, if 9 wasn't circled, it would go into those cells. It would be forced by Sudoku to go into those cells. Ah, no, hang on. Okay. Okay, I've been a bit stupid here, but that happens. Okay. That's not the question that we should have asked. The question we should have asked is, how could 9 be circled in the puzzle? And that might seem a bizarre question, and it is a bit of a bizarre question, but I'm noticing that in box 1, and indeed in box 2, it's not possible to have a full circled 9. So what I'm thinking is there are 9 Sudoku. In this puzzle, there are 9 9s, aren't there? That's all the 9s we're allowed to put in. So if you can't put a fully circled 9 into the 9 in this box, will not count as a 9. It will only count as half a 9, even if we put it in a circle. And that's going to require, in order for us to achieve 9 9s in the puzzle, there to be more than 9 9s in the puzzle. I don't know if that's making sense. Hang on, let's find all the boxes that actually have a circle in them. Yeah, okay, that box does, that box does, that box does, that box does. Yeah, so actually, look, you can actually plot them. Those cells there, if we were to try and circle 9s with full circles, we could get a maximum of those could all go in by Sudoku. It wouldn't break any rules. So we get 7 circled 9s, and we'd have to get 2 more circled 9s, fully circled 9s. But even if we put a 9 in this box on a half circle and a 9 in this box on a half circle, that would only count as 8 9s. So we'd be a 9 short. So you can't circle 8 9s in this puzzle. 9 9s in this puzzle, sorry. You could circle 8. And that means 9 is not circled in this puzzle. And that means that's a 9. Actually, it means that those circles, or those cells I showed before, are going to be all the 9s. That's a 9. We've got to put 9s in the white cells of each box, and by Sudoku this is sort of working, isn't it? We're going to get 9s in those 2, 9s in that one, and 9 there. There we go. That's all the 9s. And right, and this is going to be very important, isn't it? Because now we know. Well, now we know all the because look at this. Well, there's for more than one reason. We now know that every other digit in the puzzle is a circled digit. Yeah. Okay. So what we can do now. Oh, this is sick. Right. Okay. I'm starting to absolutely understand why everyone loves this. Yeah, because the next question we can ask is what are we doing with 1 then? That seems a very reasonable question, because in box 9, there's going to be a 1 in one of those cells, and in box 8, there's going to be a 1 in one of those cells. But we can't have more than 1 fully circled 1, can we? So there's going to have to be a half-circled 1 in this box, and a half-circled 1 in this box, and that's all the circled 1s now. So all the other 1s in the puzzle are going to go into white cells, and I can see that means that this is a 1. And it might, well, it does mean more than that, actually. It does mean more than that. It's just ridiculous. It's just, oh, it is ridiculous, actually. Yeah, no, it's absolutely ridiculous. You can just fill all the 1s in. Well, can we fill all of them in? Yes. Yes, we can. Yes, we can. Or, because those are now the 2 circled 1s, or 2 half-circled 1s. So we're going 2s or 8s. Let's go 2s. Let's go 2s, because 2s are working. Because now I'm going to look at these 4 boxes. Oh, this is, people are just going to love this, Dorlir. They're going to love it. Look, those 4 boxes of the Sudoku each contain at least a half-circled 2. So obviously they must all contain a half circle 2, otherwise we'd have more than 2 completely circled 2s, and that means 2s in the rest of the boxes are in white cells, which means that this is a 2. That's a 2. Oh, it would be good if it... no, actually, this one might not keep going. Hang on. Oh dear. Well, there's a 2 in one of those, a 2 in one of those, and I want to say a 2 in one of these. sorry, I got in. Oh, I might be going to get interrupted again. Oh dear. No, it's the weekend, and so this can happen. No, okay. I think we're all right. Okay, what on earth was I doing? Let me just go back a bit. I was putting 2s into this box. No, sorry. I think that I can now continue. Right. I was putting 2s into this box, so we were yes, because we'd worked out that we've got to put 2. The red boxes are going to contain the equivalent of 2 2s. That's what we were doing. So what should we do now? Perhaps we do pencil mark the red boxes as well, do we? Yes, we could do that. I mean, that one's a little bit restricted. 2 is down there, so 2 isn't. So 2 is a little bit restricted in box 7. 2 is a little bit restricted in box 8. Maybe this isn't what we're meant to do. Oh, no. And 2 is a little bit restricted in box 9 as well. Okay. So now I've lost my train of thought, and I don't know whether or not we're meant to look at probably 3s or 8s, I would think. Let's think about... I mean, 3s I can see something straight away. So maybe... yeah, maybe 3s, just because I can see something. So what we just did was we highlighted box 6 onwards, but if we do the same thing all the way down the grid... boxes 4, 5, 6, 7 and 8 now. Look at these boxes. Now each of these boxes has a 3 in it, and therefore the absolute minimum equivalent of circles that can be contained in boxes 4, 5, 6, 7, 8 and 9 would be if we put 3 semicircled 3s in, 6 semicircled 3s, which is the equivalent of 3 circled 3s. So that's what we must do in the purple cells, which means the 3s in boxes 1, 2 and 3 all have to be well, they have to be in white cells, that's certainly true. So that becomes a 2, 3 pair, that becomes a 2, 3 pair. And does that help us to finish the puzzle? The answer is... actually, I don't know what the answer is. It might not work. No, actually, it really might not work. 3 is in one of those cells. That's certainly true. 3 is in one of these cells, therefore, by Sudoku. There's a 2, 3 pair, look, in box 8, which gives us a 3 here. That's lovely. So we get a 3 here. There must be a 3 in one of those 2 cells now. We've got to keep the 3s in the semicircles. And yeah, this is good, I think. Where is the 3 in box 9? And I don't have a Scooby-Doo, but it's got to be in one of those cells. So now, where's the 3 in column 9, I think is a reasonable question. I think it's got to go in the corner, because it can't go in any of these cells due to we've got a 3 in one of those, so it can't be here, a 3 in one of these because it can't be in a circle, so it's not there, so it's got to be in one of those cells. So if it was here, you couldn't put a 3 in column 9. So that's 3 in the corner, that's 3 in the spotlight, losing its religion. Okay, this is going very nicely. Now can we... I know what I want to do now. I know what I want to do now. I'm just going to extend my shading very slightly like that and say, where are 4s in the puzzle? because now you can see those 8 boxes, they've all got to put 4 on at least a semicircle. So in order to keep the number of total 4s down to only 4 complete circles, each box, each of the purple boxes has to contain only a semicircled 4, and that has to be a 4. And oh, now hang on, can we do anything? So this is a 2, 3, 4 triple now in box 7. I'm sorry. I think this is going to be the world's most interrupted video. Where were we? I've just got interrupted again. Okay, I've just sat down. 2, 3, 4. We can do a 4 there by the looks of things. Now, okay, so I vaguely remember what I was doing all those moons ago. 4s have to be in semicircles in all of... Oh, yeah, in all of the purple boxes, don't they? I remember that. So 4 is in one of those 2. 4 is... Oh, okay. In box 9 then, this must be a 2, 3, 4 triple, I think, which feels like it might be relevant. Is that relevant enough? No. No, yes, actually a bit. 4, where's 4 in this box? And the answer is, I actually don't know. It's in one of 3 semicircles. But that means that 4 in column 9, look, it can't be here and it can't be here. So it's got to be up here in one of these, and there's a 4 that's helping us. So 4 and 4 can go in. And therefore we can perhaps... Well, do you think we think about... It can't be 5s, can it? Or do we go the other way? Oh, yes, we do. Oh, it's very nice. Look. Let's... In fact, this might have been available forever. I might have been solving the puzzle backwards. Look at 8. Look at 8. So how do we achieve 8 circled 8s in this puzzle? When box 1 and box 2 can't have a fully circled 8. So we are going to semicircle 8 in boxes 1 and 2. That's true. We're forced to, because there's no white cells left. So the 2 8s in boxes 1 and 2 will contribute a total of 1 circled 8 to the puzzle. And there have got to be 8 circled 8s. So every other box has to have a fully circled 8 for that to be true, and therefore that's got to be an 8. 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 Yeah, this just keeps going. I've got to make sure I fully circle 8s, I think. So... no, just all the 8s. All the 8s get done, just straight away. So let's do 7s then. Yeah, it's the same point. We were working upwards with 2, 3s and 4s from the sort of bottom. But if we work downwards from the bottom 4 boxes, look at those boxes there. Let's give those a quick purplification. Now, how many 7s are semicircled in those 4 boxes? And the answer is all of them. So the 4 7s in those boxes contribute to 2 complete circled 7s. And that means the other 5 boxes need to contribute 5 circled 7s so that we have 7 circled 7s in the puzzle. So that's got to be a circled 7. That's got to be a circled 7. One of those is a circled 7. No, that's a circled 7. That's a circled 7. And that's a circled 7. And yeah, I'm going to keep doing this. This amuses me no end. I'm now going to extend it to these boxes and think about 6s. Those 6 boxes I've just highlighted, there are no fully circled cells left. They're all semicircles. So the 6 6s in those 6 boxes contribute 3 completely circled 6s. So these bottom boxes have to contribute 3 completely circled 6s. So we've got to put the 6s in in the circles. 6, 6, and 6 again. Now, okay, yeah, there's a bit of Sudoku now, isn't there? So there's going to be a 6 up there and a 6 in one of those. Now, does that give me the 3? I've got a pencil mark. Yeah, it does. I think that gives me the 3. So now, oh, hang on. Yeah, sorry, there's a 2 here as well. I hadn't seen that. So that's a 2. This is a 3, 4 pair. This is a circled 5. Does that... Yeah, that's beautiful. That is beautiful. That's the last fully circled cell in the puzzle. So this contributes 1 circled 5, and every other box, and there are 8 of them, contributes a semicircled 5. So 8 times a half is 4, plus 1 is 5, and that gets us to the correct number of thingy things. In fact, that seems to be a thingy thing, a 5. That seems to be a 5. That seems to be a 4. Yeah, this is just, it's a superb puzzle. That's a 2, that's a 3, that's a 3, and that's a 4. And now that's a 2. I mean, is it just going to fill in? It might do. 7. There's a 7 up here. I'm slightly surprised that's not resolved. What about those 2 squares? 4 is placed in this box, so 5. I mean, we could probably do without the colouring now. Let's see if that helps us. This is a 4 by Sudoku. This is a 5. Oh, I see. Yeah, look, this is roping. 7, 8, 9, 7, 8, 9. So this is going to be 7, 8, 9, 7, 6. Do we have roping here? Yeah, 6, 7, 8, 6, 7, 8, 6, 7, 8. So this is 5, 6, 7. So that's 5. That's 6, that's 7, that's 5, that's 7, that's 6, that's 6, and that's 5. And the puzzle's finished, out of nowhere. That is just, it's spectacularly brilliant, Dorlir. It's so original. Well, yes, it is original, because Dorlir's taken something that we all were familiar with, which are the circles, the full circles, and sort of completely rejuvenated it in the most beautiful way. Oh goodness, that is a spectacular puzzle. I absolutely loved it. I hope you did too. Let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind, and I'm going to get... Alright, I'm not going to get interrupted again because I'm going to close the video. Yeah, let me know in the comments. That would be good. Bye for now.